So what we're going to do is sum and difference of functions. Maybe because there's so many people missing, I might revamp. I might do sum and difference and multiplication and division, but just do graphs on Monday. Okay, sum and difference, multiplication and division. So what I'm going to do is I'm going to give you a function, an f function and a g function, and then make you add them, subtract them, multiply, or divide. So this is what you should note. So if I give you h of x equals f plus g of x, what that actually means is you're just going to do f of x plus g of x. So if they're written together like that, f plus g of x, I would just rewrite them as expanded. If you have h of x equals f minus g of x, you would rewrite that as the f function minus the g function. And then if h of x is f times g, so closed dot here. Closed dot is important because a closed dot means multiplication and an open dot means composition, which we will do on Tuesday. So if it's a closed dot, it's multiplication. So we're going to get f of x times g of x. And then h of x equals f over g of x like this. That's the same as f of x divided by g of x. So we'll just do equations today and graphs on Monday. So if they're written in that middle form, always change them to the last form because it makes more sense. So example 1, the two functions we're going to use are f of x equals 3x minus 5 and then g of x equals negative x plus 2. Now what we're going to have to do is the operation to the functions that I ask you to do, but then often you're asked to find the domain and range. Okay? So we're going to actually do each operation. We're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. Okay? So, A. We're going to do h of x equals f plus g of x. What does that just mean? You said, you are correct. So we literally just add the two functions. 3x minus 5 plus negative x plus 2. Then what can we do? Select like term. So we get 3x minus x, which is 2x, and then negative 5x plus 2, or negative 5, sorry, plus 2, which is negative 3. So our combined function is literally just a line. We agree? So what's the domain of a line? Negative infinity, positive infinity. And what's the range of a line? YER. Or negative infinity, positive infinity. I'll be floating back between both forms because you have to know both forms. So that's addition, right? Then we have subtraction. H of x equals f minus g of x. which is just the same as f of x minus g of x. So it equals 3x minus 5 minus negative x plus 2. I missed something. What did I miss? I didn't need this for a plus sign, but I do need this for a minus sign. Brackets. Because you have to remember to minus all of g of x. And right now, am I minusing all of g of x? No, I'm just minusing the x of g of x. I need to minus all of g of x. So don't forget those brackets. Do you think the answer will be there if you do forget the brackets? Absolutely. So we get 3x minus 5 minus x is plus x minus positive 2 is negative 2. And then collect like terms. 3x plus x is 4x. Minus 5 minus 2 is minus 7. So it's a line as well. So what are we going to do? Graph it, and then we know our domain is XER, YER. So remember, this is set notation. This is interval notation. Why are you on your phone? C. H of x equals f close dot g of x. What does the close dot mean? So we're going to do f of x times g of x, which means we're multiplying two linear factors. So remember when you solve a polynomial or a quadratic, when you factor them, you actually end up with linear factors, like x plus 3, 2x minus 1, x minus 4. Those are linear factors. Linear factors are just lines, okay? So right now we have two linear factors. We have 3x minus 5 multiplied by negative x plus 2. So we actually have two lines that make this up. We have the line 3x minus 5. If we drew the line 3x minus 5 and we drew the line negative x plus 2 and we multiplied their y's together, we'd get the new function. So we have two linear functions that we're multiplying together to make a quadratic, correct? So when you do x cubed and it asks you for the linear factors, it literally just wants you to factor it down. If it asks you to solve, or the zeros, or the roots, or the x-intercepts, I'm asking you to go that extra step and tell me x equals that. Okay? So if I ask you to factor, you're done at the factors in polynomials. But if I ask you to solve x-intercepts, roots, zeros, I'm asking you to give me x equals. You have to go that extra step. Okay? So, am I done? No. I have to FOIL. So I get 3x times negative x, which is negative 3x squared. 3x times 2, positive 6x. Negative 5 times negative x, positive 5x. Negative 5 times positive 2 is negative 10. Combine like terms, get negative 3x squared plus 11x minus 10. Then there's going to be those of you who are going to try and factor it again. You're just going back to where you were. Stop. Don't do that. You will. You'll be like, I can factor it. What times do I get? I'm like, you had them. Don't. No point. Or there's those of you who now you're going to set it equal to 0 and solve. So what you need to do is you need to actually write h of x equals, h of x equals, h of x equals. Why would I have to write that all the way down? Why would that be helpful? That's what the thing is. And you won't try and set it equal to 0 because it's equal to h of x. You guys will. You'll go 0 and then you'll factor it and then you give me some x equals. And I'm like, no, stop. Okay? It doesn't say solve, it'll say simplify. Remember, solve means x equals, right? If it doesn't say solve, you're not getting to x equals. Okay? All right. Oh, and then division. So we're going to get f of x divided by g of x, which actually gets us a rational. So it's quick to be done. 3x minus 5 over negative x plus 2. We can't simplify because remember this is attached with the plus sign, this is attached with the minus sign, so they're attached together. So I can't make them any more simple, can I? But there is a step I have to remember because now I have a variable in the denominator. State, NPVs, or restrictions. So behind this, I'd have to say x cannot equal 2. That would actually be the answer. So what's the domain of this one? No. What's my range? Nope. If there is an x that does not equal, there's also a y that does not equal. Remember there's asymptotes. Remember the unit that you're going to have a test on is in with this. It's rationals. So the bottom gets you the vertical asymptote. So x can't equal 2. What does y can't equal? They're the exact same degree. Degree 1, degree 1. What do you do? Three over negative 1. So what is it? It is smart. Yeah, it's a quadratic. So we know that our domain is XER. How do we get our range? We need our what? Y. This is concave down, so it's not a min. Yes. So it's going to be y such that y is less than or equal to the max. Find the max. Go. It's not 10. That's the y-intercept. Okay, if it's 0.08, we'll write 0.1 YER. Okay? So linear ones aren't too bad. Let's go and do some that are a little harder. So example 2. F of x equals, and this is why we learn radicals and rationals ahead of this unit, because we're going to have questions with radicals in it and questions with rationals. So f of x equals 3x squared plus 2 and then g of x equals square root x plus 4 and h of x equals 4x minus 2. H of x isn't always what it equals, guys. Like I can just go like f plus g, h plus g, g minus h. I can do it in whatever form. You could do y equals or whatever. But I'm going to tell you which ones to do. Okay, so the biggest hardest part in this question is actually the square root. If the square root is involved in any adding, subtracting, multiplying, dividing, you're going to have a restriction. Just like with rationals, we have a restriction on our x based on our denominator. We agree? With radicals, we have a restriction if we have a variable under the radical because we can't have what under a radical? Negatives or zeros. So if I have square root x plus 4, x is going to have to be greater than or equal to negative 4. Because if I plug in negative 4, I get negative 4 plus 4, which is 0. If I plug in negative 5, I get negative 5 plus 4, which is negative 1. Can I take the square root of a negative 1? So I know that this domain is going to help us out and exist when we start putting the functions together by addition, subtraction, multiplication, division. Okay? Because that's going to limit my x's instantly if this equation is involved. Remember, the great thing about this is you can punch them in your calculator and see what it looks like as well for your domain and range. Yeah. Yeah. Because you can take the square root of 0. Yeah. The only time it can't be equal to is when it's like the domain and range of exponential and a log because you can't equal the asymptote. Can you take the square root of 0? What's the square root of 0? It's 0. So you can take the square root of 0, so it can be equal to -4. Okay. So I want you to do y equals f of x plus h of x. For A, I want you to write it out, and then give me domain and range. B, I want you to do g of x, oops, y equals. That's how you can work, one at a time, sure. G of x minus h of x. And then C, y equals square root x plus 4. Oops, I'm giving you the answer. Equals g divided by h of x. So try those out. Okay, we're going to get y equals 3x squared plus 2 plus 4x minus 2. So we get 3x squared plus 4x. For those of you who are setting this equal to 0, factoring and solving, stop. No. Y equals this. It's an equation. I didn't ask you to solve. Just asked you to put them together. Please stop it. You guys do it on the test all the time, and I have to mark every single answer wrong because you just keep going. Like, you're done. Stop. No, no, stop. Okay, when we type this one into your calculator, what is your minimum? The fact that you don't know right now means no one typed into the calculator. Awesome. So when we find our minimum, we take our y value. Now the y value is repeating decimal, so I'm going to go to my main screen. I'm going to go alpha 1, math, enter, enter, and it turns into -4/3. Y such that y is greater than or equal to -4/3. Get proposed of y. Alpha 1 is y. Okay. Now this one is y equals g of x square root x plus 4 minus, I put this in brackets, 4x minus 2. The hardest part of this equation is remembering the minus sign. Goes to both. So your answer is square root x plus 4 minus 4x plus 2. Type it into your calculator. Can't make it any prettier because there's no like terms. Yep. Nope. Because they're replacing stuff, right? Or not going in. I can't put them in. Okay, so why does this graph start at x is greater than or equal to 4? Or -4, sorry. Because that's the domain of this one, and this is in here. So the domain is x such that x is greater than or equal to -4. How could I find my range? No, once you have it in your calculator, you need to find the y that goes with that x. So I know x equals -4. How can I find the y that goes with it? Throw your phone on the floor. That is what you do. Okay, you do second trace value. X equals what? 0 is not helpful in this situation. I'm not finding the y-intercept. -4. Holy. We want to find the y that correlates with -4. What do we put in? 0, 1, 72. -4. We just want to find the y that correlates. Oh, -4. 18. So y such that y is less than or equal to 18. Why is it? Do you have it on your calculator? Does it look like it's lower than 0? G divided by h. So we have y equals g, which is square root x plus 4, divided by h, which is 4x minus 2. Is there anything I can do to that? Yes, but there's nothing I can do to the equation. So I'm going to type it into my calculator. I'm going to go bracket square root x plus 4. Oh, stop the madness. Oops. Yeah. Yeah. You'd move the 2 over and divide by 4, which is a half. I was excited. I'm not going to lie. That was good. Yeah. Yeah. So we know that x can't equal a half. We know because we have the radical that x is also greater than or equal to -4, because these are two restrictions we have in this, correct? We agree? So if we make our y max big enough, 100, let's say. The domain of this graph is literally just going to be those combined, right? It's going to be x has to be greater than or equal to -4, but x cannot equal a half. So remember, whenever you have a rational, you have a non-permissible value most of the time. When's the only case we won't have a non-permissible value in our denominator if we have a rational? If you have an addition of squares. X squared plus 4. If you had something like this in the denominator, there's no way that that can ever be 0. No matter what you fill in for x, it's going to be positive. Positive plus a positive is positive. It can never be 0, right? It's the only time you won't get NPVs is when you have an addition of squares. Only that. Other than that, you will get a denominator NPV. If you have a radical, you're going to get an NPV, unless you have an addition of squares underneath the radical, because that won't get us any negatives, right? We agree? So we have to encompass both of these. So we have x is greater than or equal to -4, and x cannot equal a half. And the range I won't worry about. D, we have y equals 3x squared plus 2 times g, which is square root x plus 4. If you wanted to distribute it, you could. And you get 3x squared times square root x plus 4, which is 3x squared times square root x plus 4. Yep, because that's how I said it. And then 2 times square root x plus 4. So with the square root x plus 4, we have issues. What's the issue for x's? Yeah, you can. X has to be greater than or equal to? It can equal 0. Yes. We're going to, yeah. Yep. Okay. Okay. So remember, if you have that radical, you have a problem with your domain. That's the key thing to take here. So for your homework, I'm going to give you some questions.